All right, so now we're going to get into the second half of 4.2. So in the first video, we talked about the different angle relationships that we saw pop up. And now we're going to take it one step further and use those angle relationships in order to help us solve these problems. Okay, so we got 6 that we got to work through. So example 1, we are asked to find the value of A and then explain our reasoning. So they give us this picture here. Okay, so these two lines are parallel. We know that because of these arrows that they put on these lines. Those mean that they are parallel lines. So we've got two angles that are marked. We've got this angle right here marked as 2A degrees. This angle marked as 54 degrees. So given just that little bit of information, we need to determine what the value of A is. So I'm looking at this pair of angles and I need to determine kind of what's the relationship here. So both of these angles are in the exterior, okay? They are outside of my parallel lines. So they're both on the exterior. Okay, so if these are my parallel lines, this line right here is the transversal that's cutting through my parallel lines and thus creating all of these angles. And as we see, both of these are on the left side of the transversal. So they're both on the same side of the transversal. They're both in the exterior. So these are same side exterior angles. So now we have to think back, are same side exterior angles, are they supplementary or are they congruent? Because all the angle relationships we talked about was one of those two, and they are indeed supplementary. So I can add these two together, 2A and 54, and set it equal to 180. Okay, so then from there, it's just simply doing a multi-step equation. So I subtract 54 from both sides, and I get 2A is 126. Divide both sides by 2, and I get that A is just 63. And we're just going to leave it just as 63. With some of these, we may put a degree symbol on them, but since the A doesn't actually represent a degree, we're just going to leave it just as A is 63. All right, let's look at example 2. Okay, so example 2 tells me to find the values of X and Z, and then go through and explain our reasoning. So we begin with, again, two parallel lines. Here, we know that by the arrows, and transversal cutting into them. We've got this angle marked 3x minus 15 degrees, this angle marked z plus 25 degrees, and this angle marked 105 degrees. Okay, so we got a couple different ways we can go about this, just depending on which one you want to solve for first. I'll solve for z first. So if I want to solve for z first, okay, so I know off the bat that 3x minus 15 is z plus 25. These are right next to each other, sitting on a straight line, which means they make a linear pair. But given that I've got two variables, if I try to set up that equation, I don't want to do that just yet. I'm not ready for that just yet. Okay, so let's try to solve z with another way. So z plus 25 here, and the 105 is the only other angle that they give me. So I got to ask myself, what's the relationship there? So z plus 25 and 105, they're both in the exterior. Z plus 25 is on the right side of the transversal. 105 is on the left side of the transversal. So that means they're on alternate sides. So alternate exterior angles. Okay, so then I have to ask myself, are alternate exterior angles supplementary or congruent? And they are congruent. So I'm going to set these equal to one another. Z plus 25 is 105. And that's because they're alternate interior angles. So then subtract 25, and I get that z is equal to 8. So now I need to go through and solve for x. Okay, so now that I am able to plug in z right here, I can plug it in and get 80 plus 25, which is just 105. So I say that 3x minus 15 plus 105 will be equal to 180, because again, these make a linear pair. Okay, so I combine my like terms. Negative 15 and 105 will make positive 90. So I have 3x plus 90 is equal to 180. Then I subtract 90 from both sides, and I wind up with just 3x is 90. And then I divide both sides by 3 to get x is equal to 30. Again, with both of these, we're just going to leave it at just z is 80, x is 30. We're not going to put a degree symbol on it just because it doesn't represent an actual angle, just a piece of it. Okay, example 3. So example 3, we need to find the values of m and n, and then explain our reasoning as we go along. So explain our reasoning just tells me what angle relationship are you using to justify this. So we've got an angle right here, n plus 12, an angle right here, m degrees, an angle right here, 114 degrees. So depending on whichever one you want to solve first, it doesn't really matter. I'll start with n. So I know n plus 12 and m, that won't really work because I got two variables there. So I'm going to look instead at n plus 12 and 114. So these angles are both in the exterior. They're not inside the parallel lines. N plus 12 is on the top side of the transversal. 114 is on the bottom side. So these are alternate interior angles, which tells me they're equal to one another. So I set it up as n plus 12 equals 114. Subtract my 12, and I get n is 102. So now I know that. I can set up to solve for my m. Okay, so a couple different ways you could do it. I just said that m plus 114 is 180. Okay, and I said it because this and this, they are same side exterior angles, both on the bottom side of the transversal, both in the exteriors. So m plus 114 is 180 because same side exterior angles are supplementary. Subtract 114, and then I said m is 66 degrees. This time I put the degrees symbol on there because the variable we were solving for was the actual angle. It wasn't like m minus 2 or m plus 15. It was just m. So that's why I said this one was 66 degrees. All right, so example 4. Example 4 tells me find the values of a and b and then explain your reasoning. So this time they changed it up. So it's not just a couple of lines and a transversal. They kind of almost made a shape on us now. Okay, but they still labeled two parallel lines. And so that would mean that these other two lines are also kind of considered our transversals. So we are given a and b to solve, and we've also got an x in there too. So we'll just go ahead and solve for that x as well. So right off the bat, so I'm going to start with a. So I've got 3a plus 40. So I know I've got a linear pair with 3b minus 70, but that helps me none because I got two variables. I know that I've got these two right here. That could work too, but that's, again, another variable. And now I've got 3a plus 40 and 120. And it might be a little bit weird to see, but those angles are going to be alternate interior angles, okay, because they're both inside the parallel lines and they're both on opposite sides. So we're going to consider those alternate interior angles, which means they're equal to one another. So we can say 3a plus 40 is 120. We subtract 40 from both sides, get 3a is 80. And then it's okay to sometimes get some weird looking answers. Okay, so this one will wind up being like 26 2/3, but we could round that off to just 26.7 approximately. Okay, so now we know that this 3a plus 40 is basically just equal to 120. So if we want to solve for b, we can come over here. So we have 3b minus 70 plus 120 is equal to 180. And this is because these two will make a linear pair. So I combine my like terms. Negative 70 and 120 will give me 50. So I've got 3b plus 50 is 180. Subtract 50 from both sides, and I get 3b is 130. And then I'm going to divide both sides by 3. Again, I'm going to get a weird answer. It's going to be 43 1/3, or 43.3 repeating. We're going to just approximate that to just 43.3. Okay, and then lastly, this x, they didn't tell us to solve for x, but I don't know why they would put it there if they didn't want us to solve for it. So we'll say that x and 120, they will be same side interior angles. So we set it up. X plus 120 is 180 because same side interior angles are supplementary. Subtract my 180, and I get that x is 60 degrees. All right, let's look at number 5. Number 5, find the values of j and k, and then explain your reasoning. So again, it gives us a picture. These top and bottom line, those are my parallel lines. The other lines will be considered my transversals. So right off the bat, I know that 2K and 102, a little bit weird, but they are going to be alternate interior angles, okay? Because if we were to extend this line and extend that line right there, this line is our transversal. These are our parallel lines. So now it makes it a little bit easier to see these are alternate interiors. So alternate interior angles are congruent. So we set it up as 2K is equal to 102. Divide both sides by 2, and we get that K is 51. Now we want to determine 5J, or determine the value of J. So we look at 5J and 110. Again, if we were to extend these lines, we can see that 5J and 110, they're in the interior, and they're both on the same side of this transversal. So 5J and 110 will make a same side interior angle pair. Same side interior angles are supplementary, so we set it up as 5J plus 110 is equal to 180. We subtract 110 from both sides, we get 5J is 70, and we divide both sides by 5, and we get that J is 14. All right, last one, example 6. Find the values of C and D and explain your reasoning. So we are given these two parallel lines, these two transversals, and then another line that kind of cuts in there. So this is where it can get a little bit weird, okay? Because that line kind of cuts it and creates more angle pairs. Okay, because normally, if we were looking at this and, we could extend these lines, maybe make it a little bit easier for us to determine some of the stuff we're talking about. But this whole angle and this whole angle, in a way, would be considered alternate interiors. But then when we cut that thing in half, it creates a whole other set of alternate interiors. Because now we have to go across another line. So now basically the two angles that are dealing with a C are alternate interiors, and the two angles that are dealing with, and the two that are with the D are involving alternate interiors. So now we've got two sets of alternate interiors inside an original pair of alternate interiors. So if we want to solve for alternate interiors, they are congruent to one another. So we're going to set 2C minus 15 equal to C plus 55. We bring our C over here, we add our 15 over here, and we get C is 70. Same thing with the 2D. So 2D and 60, alternate interiors, set it equal. 60 is equal to 2D. Divide both sides by 2, and we get that D is equal to 30.